Hello everyone, in this video we're going to talk about electric charge. First of all, let's take a look at two demonstrations here. For the first one, the two glass rods were each wrapped with a silk cloth, and one was suspended by a thread. When they are close to each other, they repel each other. For the second one, the plastic rod was wrapped with fur. When brought close to the glass rod, the rods attract each other. So we can see there is repulsive force in the demo A and there is attractive force in the demo B. After a great many investigations, scientists figured out that the forces in these types of demonstrations are due to the electric charge that we set up on the rods when they are in contact with silk or fur. Electric charge is an intrinsic property of the fundamental particles that make up of objects such as the rod, silk, and fur. That is, charge is a property that comes automatically with those particles wherever they exist. And by the way, we use the letter Q. We use the letter Q to represent electric charge. Sometimes it's capital, sometimes it's small. And the unit of electric charge is Coulomb, and we use the capital C to represent. There are two types of electric charge named by the American scientist Benjamin Franklin as positive charge and negative charge. He could have called them anything, but using algebraic signs as names comes in handy when we add up charges to find the net charge. In most everyday objects, such as a mug, there are about equal numbers of negatively charged particles and positively charged particles, so the net charge is 0. And the charge is said to be balanced. The object is said to be electrically neutral, or just neutral for short. Normally, you are approximately neutral. However, if you live in regions where the humidity is low, you know that the charge on your body can become slightly unbalanced when you walk across a certain carpet. Either you gain negative charge from the carpet and become negatively charged, or you lose negative charge and become positively charged. Either way, the extra charge is said to be an excess charge. You probably don't notice it until you reach a door handle or another person. Then, if your excess charge is enough, a spark leaps between you and the other person, eliminating your excess charge. So such charging and discharging does not happen in humid conditions because the water in the air neutralizes your excess charge about as fast as you acquire it. With lots of experiments similar to our two demonstrations here, scientists discovered that the particles with the same sign of electrical charge repel each other, and particles with opposite signs attract each other. Now, let's go back to the demonstrations to understand the motions of the rod. When we rub the glass rod with a silk cloth, a small amount of negative charge moves from the rod to the silk, a transfer like that between you and a carpet, leaving the rod with a small amount of excess positive charge. When we rub the second rod with the silk cloth, it also becomes positively charged. And so when we bring it near the first rod, the two rods repel each other. Next, when we rub the plastic rod with fur, it gains excess negative charge from the fur. Again, the transfer direction is learned through many experiments. When we bring the plastic rod near the hanging glass rod, the rods are attracted to each other. All this is subtle. You cannot see the charge or its transfer, only the results. So finally, we're going to introduce a key idea. When we connect the two identical spheres, they end up with identical charges with the same sign and the same amount. The initial sum of the charges must equal to the final sum of the charges, or we can use the equation to represent the statement. Q1 equals Q2 equals Q1 plus Q2 or minus Q2 divided by 2. For example, we have two spheres here, A and B. Sphere A has a positive charge of Q, and sphere B is electrically neutral. When they are wired together, the negative conduction electrons on B, which repel one another, have a way to move away from one another along the wire to positively charged A, which attracts them. As B loses negative charge, it becomes positively charged. And as A gains negative charge, it becomes less positively charged. The transfer of the charge stops when the charge on B has increased to Q half, and the charge on A has decreased to Q half. So that's all for this lecture. Thanks for watching.